All right, the second objective in section 4.1 is to evaluate polynomials using direct substitution and using synthetic substitution. All right, so direct substitution, synthetic substitution. All right, and that we're just evaluating here is all we're doing. All right, so let's see how this is going to look. All right, here is a function, f of x equals 2x to the fourth minus 5x cubed minus 4x plus 8, and I want you to find f of 3, all right, which means plug 3 in for x. We're going to have to take 2 times 3 to the fourth minus 5 times 3 to the third minus 4 times 3 plus 8. What's 3 to the fourth power? Well, that's 81. All right, if you don't know that, your calculator will. What's 3 cubed? Well, that's 27 minus 12 plus 8. 81 times 2, I think that's 162. 27 times 5, I'm going to say that's 135. So 162 minus 35, well, I'm doing this in my head, so it takes 15, it takes 25 to get to 160, so I think that's 27. All right, 27 minus 12, I think that'll be 15, plus 8 gives us 23. So, how do you find f of 3? Well, to use direct substitution, you just plug it in and evaluate. All right, I did it all in my head. Calculators are fun for that stuff too. Okay? Well, there's a different way to do it, and it's called synthetic substitution. So let's see if we can do that. In synthetic substitution, what we do is we just take the coefficients from the polynomial, we write them right here, and we make a little box over here, and we say, okay, if I want to find f of 3, that's when, that's saying that x equals 3, correct? And if we had in factored form, how do you get x equals 3? Well, you use minus 3. And so, that's what we're going to do here. I'm going to plug. So, what I'm going to do, never mind this. This is just, don't worry about what I was talking about here. We're going, if we want to find x of 3, then I'm going to put 3 in here. I'm going to draw a line underneath this, and I'm going to go drop the first term. 2 times 3 is 6. Add these together. Negative 5 plus 6 is 1. Multiply 3 times 1, that's 3. Add negative 1. Multiply by the 3. Add, and I get 5. Now, wait a second. We should get the same thing that we got in the last problem. It's the same problem. It's the same thing. And we got 23 just a second ago, didn't we? And now we got 5. So something's screwed up. Well, I see what the problem is. All right? Did you notice that when I wrote the coefficients here, do you notice that there is an x squared term missing? And so now I've got to put a 0 where that x squared would be. So it's 2, negative 5, 0 where the x squared should be, negative 4, and positive 8. Now I can do drop the first one and multiply. Add, multiply. I'm sorry. Yep, multiply. Negative 4 plus 9 is 5. 3 times 5 is 15. 15 plus 8 is 23. And so we got the same answer as we got on the other page. So synthetic substitution, to me, I can do a lot of longer problems just a little bit quicker. All right? Now, there may be times where you would rather use direct substitution. That's fine. But this synthetic thing will be great if you remember to put your placeholders of zeros in there. If you don't remember to put your placeholders in, you can really mess yourself up. All right? Good luck.